I'm Anil Kumar. Welcome to my series on exponential functions and logarithmic applications. We will now consider challenge examination questions based on application of logarithms in this particular video. I have selected two of them, which are right before you. You can always pause the video, answer these questions, and then look into my suggestions. The first extended application is the variable x and y satisfy the formula 4 to the power of y equals to 5 to the power of x plus 3. Show that the graph of y against x is a straight line. Find the exact value of gradient and y-intercept of this graph. Extended application 2. The variable x and a satisfy the formula a equals to k b to the power of x, where k and b are constants. The graph of log a against x passes through the point 0, 0.4 and 5, 0.9. Find the value of b and k. Justify your solution. So these examples are based on converting nonlinear curves into linear curves using logarithms. So that is the hint for you. So you can take log on both the sides, and once you do that, you find that these relations could be represented as a straight line. So when we say that this is being represented as a straight line, you could do it by converting them into logarithmic form, right? Now let's take their solution one by one. Extended application 1. The variable x and y satisfy the formula 4 to the power of y. Let me rewrite this formula. 4 to the power of y equals to 5 to the power of x plus 3. Now this has two parts. The first one is show that the graph of y against x is a straight line. And the second one, find exact value of the gradient and y-intercept of this graph. So let's do part A, which is show that the graph of y against x is a straight line. Now to do that, let me take logs on both the sides. So first step will be take logarithms. On both sides. Now you could also do one more step before this, and that is you could write this exponent x plus 3 as a product form, correct? So let me do that part first. So I'll write this as 4 to the power of y equals to 5 to the power of x times 5 cubed, right? Now we are going to take logarithms on both sides. We get log of 4 to the power of y equals to log of 5 to the power of x plus, because that is a product, log of 5 cubed. You could write this as y log of 4 equals to x log of 5 plus log of 5 cubed, right? Okay. So we could just write this as, you could write 125 if you want to, or you can write log of 5 cubed. So let's write 125, which is 5 cubed, right? 125, 5 times 5, 25 times 5. Okay. So from here, you can actually write y equals to what? So y equals to x log of 5 divided by log of 4 plus log 125 divided by log of 4. Now, does that represent a linear relation or not. That is what you have to think about. So what you notice here is the part given to us is in the form of y equals to mx plus b. Is that so? Well, if you relate it, you can write m as equal to log of 5 over log of 4, and you can write the y-intercept b as equal to log of 125 over log of 4. Okay? So now, first thing, we want to show that the graph of y against x is a straight line. So this equation right there is equation of a straight line, right? You know why? Because log of 5 over log of 4 is a constant, and the y-intercept b is also a constant. These two terms are constants, and we could actually write them in the form of y equals to mx plus b. So if you compare clearly from here, what you notice is that m is this part, correct? And the y-intercept is right there. So it is of the form of y equals to mx plus b, and therefore it is a straight line. So we have done part A. Now look at the part B, which is find exact value of gradient. So the exact value of the gradient means the slope is right there. Ratio of log 5 to log 4. And y-intercept is here. Do you see that? So that is how you could answer the very first question. Now, let's take the second one. Extended application 2. The variable x and a satisfy the formula a equals to k b to the power of x, where k and b are constants. So it's an exponential equation. The graph of log a, so we have log a here, and x passes through these 2 points. So these 2 points are given to you, 0, 0.4 and 5, 0.9. Find the value of b and k. So basically you have to find these constants. So I hope the question is absolutely clear. Now let us see how to solve this particular question. Now since we are given a straight line, which is a graph of log a versus x, it's a good idea to begin with taking logarithms on both the sides. So let's take log on both the sides, right? So let's do the same thing as we did earlier. So take log, I'm writing in short form on both sides. So we get log of a equals to log of k plus x times log of b. So we use the power rule, right, along with the product rule, so log of b. Now this definitely is in the form of a straight line. Log of a, we will rearrange. So x slope being log b, y-intercept being log k. So that is the equation which is similar to y equals to mx plus b. So the gradient m is log b for you, and the y-intercept b is log k for you. Is that clear to you? So that is how they are connected. So as we see that the graph of log a versus x will be a line, straight line. Correct? as shown. Perfect. Now, we are given the y-intercept and a point on this particular line. That should help us to find the values for m and b, correct? So that's the key. So I'd like you to now pause the video and find out the value of b and k, which is part 2 of this particular question, which is find the value of b and k. And then we have already justified our solution, but now let's try to figure this out. So what we have calculated from here, that the gradient m is equal to log of b, and that actually tells you that b is equal to 10 to the power of m, the gradient. And we also see that log of k is equal to the y-intercept, which is this is the other b, right? So I should say intercept, y-intercept, right? So k is 10 to the power of the y-intercept. Let me write y-intercept. Otherwise, you'll get confused with the two b's which we are using, right? So one b is a part of the equation, the other one is the y-intercept. Let me rather change this to c. Okay, let's write this as c so that that confusion is not there. So that makes sense. So log k will be equal to c, and so k will be 10 to the power of c. Is that clear to you? Where c, the y-intercept, is this point. Perfect. So that is how you're going to figure this out, right? Now you can always use the calculator. Since we know these values, we can calculate the answer. So we have the value of b as equal to 10 to the power of slope m. So we need to calculate the slope here and then find the answer. So let's do it on a fresh page. So once again, we are right there. So we just figure out that a equals to kb to the power of x, and we saw that log of a is equals to x log of b plus log of k. I'm reworking on it, and there was a confusion. So we said y equals to mx plus c, where c is the y-intercept, and we are now saying that the slope or the gradient m is what log b is. Log b is m. Now let's find what m is. So m is this particular gradient, change in y value over change in x value. So this value is 0.9, take away 0.4 over 5 take away 0, which is 1 over 10, right? 0.5 over 5, 1 over 10. So that is the value of m. So from here, we get the value of b as 10 to the power of 1 over 10. Now we can use the calculator to find this value. So it is 10 to the power of, let's say, 0.1. And that gives us 1.2589. So 1.2589. So I'm rounding it to 6. So that is the value of b for us. Correct? Now let's find the value of k. So we have log of k equals to the y-intercept, which is c, and which is equal to 0.4. So k will be equal to 10 to the power of 0.4, which is 10 to the power of 0.4, and that is equal to 2.511. So I'll write this as 2.5. You can write 0.1. Okay. So that becomes the value of k, and that gives you the relation. Let's rewrite the relation now. A is equal to k is 2.51, and the value of b is 1.26 to the power of x. So that becomes your relation. Perfect. And we have both the values as required, a, b, and k, where the value of b is 1.26 and the value of k is 2.51. Perfect. So that is how you're going to solve this. Now these two questions are extremely important from examination point of view. So I'd like you to go through it once again, try to understand all the concepts so that you ensure that you get good marks. Thanks for your time and all the best.